Today's section is 1.5 angle relationships. So by the end of the lesson, you should be able to identify and use special pairs of angles and perpendicular lines. So the first type of angle pair we're going to look at is adjacent angles. So adjacent angles are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. So meaning the angles don't overlap one another. So if we look at the images that they have here, the examples, so you notice how in this first one, ABC and CBD are adjacent angles. They share that common vertex of B, they share the common side of BC, but they don't touch one another, they don't overlap. Same for the second drawing. Now non-examples, and you're going to look at this first one and say, well, that one looks a lot like the very first one, but let's look at the angles they're referring to. It's saying ABC, so that's the first one, so that one's good, but then it's talking about ABD, because ABC and ABD, they both do share that common vertex, and they share a common side, but the part that they don't meet is it says they have no interior points. Well, this one they do. They have point C as the interior point, so that's why those are not adjacent angles. Think of your yard and your neighbor's yard. They're adjacent, but they don't overlap. They're just sort of side by side. All right, the next pair is vertical angles. So vertical angles are two, non-adjacent angles formed by two intersecting lines. So I'm going to number these. So the examples of vertical angles are A, E, B, so I'm going to call that angle 1. CED, so I'm going to call that 2. So vertical angles are sort of across from each other. Okay, they make that V, two V's back to back. All right, so those are the first two. The second set is AED, so this angle, and BEC, so that angle. So I'm going to call that one 3 and this one 4, so that way you can see them. So angles 1 and 2 are vertical, and angles 3 and 4 are vertical. Okay, you can look at that non-example then. A linear pair. So a linear pair is adjacent angles, so think, they have to be side by side, but they have with non-common sides that are opposite rays. Because adjacent angles do have a common side. So what it's saying is the side that's not in common, the side that is not touching itself, are opposite rays. So that means it's going to make 180 degrees. Okay? The last two, I'm sure you're pretty familiar with, or at least maybe you've heard about them before, are complementary and supplementary angles. So complementary angles are two angles whose measure has a sum of 90 degrees. Okay, complementary is 90 degrees. Supplementary are two angles with measures that have a sum of 180 degrees. So if I add the measures of their angles, it equals 180 degrees. The one thing that you may or may not know is that complementary and supplementary angles, they can either be adjacent, so here's the adjacent ones, but they don't have to be. So if you look at this, these two angles, PQR and XYZ, 50 plus 40 is 90. So they're complementary angles, they just don't have to be side by side. The same for these two angles down here, angle M and angle N. 80 degrees plus 100 degrees is 180 degrees. Now the way I usually tell people to keep these two straight, think of the alphabet, think of your number line. C comes before S in the number line, C comes before S in the alphabet, and 90 comes before 180 on a number line. So complementary is 90, supplementary is 180. So just a little trick to help you remember which is which. And last but not least, we're just going to remember some facts about perpendicular lines that I'm sure you learned about in Algebra 1. So the first one, it says perpendicular lines intersect to form 4 right angles. Now they don't have to show that they're all 4 right angles, as you can tell in this image. They only showed that one was right. But we know that they're all right angles. Perpendicular lines intersect to form congruent adjacent angles. They're congruent because they're all 90 and adjacent because they're side by side. Segments and rays can be perpendicular to lines or other segments and rays. And the last one, it says the right angle symbol in the figure indicates that the lines are perpendicular. And then the symbol we use, so in the drawing we put that little right angle symbol, but down here the symbol for perpendicular is like an upside down T, so two intersecting lines that would form right angles. All right, one more fact about vertical angles, we'll sort of keep them both so you can see them, is that vertical angles are congruent, meaning they have the same measure. So if I told you that angle JPL was 120 degrees, you would be able to find all the other angles. You would know that KPH is 120 degrees, but then KPL, that's a linear pair, and linear pairs are 180, so that must mean this is 60 degrees. And then this angle over here is also 60 because they're vertical. All right, so knowing these definitions is going to be key for today. All right, let's take a look at the first example. It says, use the diagram below to answer the following questions. Name two angles that form a linear pair. All right, there are actually many, but we're just going to look and see which ones we can find. So a linear pair means they are adjacent and they add up to 180 degrees. So we could do 115 plus 65, which would be these two angles here. And if you add them, we get 180. So I'm just going to go ahead and write those down. I'm going to do XZV, so angle XZV, because remember, when we name an angle, that vertex always has to be in the middle, and angle VZY. All right, that's one answer, but there are many. All right, second one, name two acute vertical angles. So let me erase that, acute and vertical. So acute, remember from yesterday, less than 90 degrees. So 50 is less than 90, all these 65s are less than 90. The 115, not less than 90, so we can forget about that one. But vertical means they have to be opposite each other. So I'm going to go ahead and pick those two. So I'm going to do angle VZY and angle XZW. All right, moving right along to example 2. I passed. All right, so example 2 is probably everyone's least favorite. If I were you, I would put a star next to this, highlight it, do something, because I guarantee you this is the kind of question when we get to the end of the year, final exam, you're going to forget how to do. It's not that it's difficult, it's just a lot of people don't care for it. So keep a note about this one. So it says find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the other angle. So two supplementary angles. That tells me I have the measure of angle 1 plus the measure of angle 2, and that should equal 180 degrees, because that's what supplementary means. So that means we have to have two angles. I have to have an angle 1 and an angle 2. I'm going to go ahead and put the measure of them. So we don't know either of them. So I'm going to go ahead and say, okay, angle 1 is going to be x. And the reason we need to do that is because it says one angle is 6 less than 5 times the other angle. So to write the measure of angle 2, I need to have something that represents angle 1. So 6 less than, so that's minus 6, 5 times the other angle. 5 times the other angle, well, that is x. So now I can substitute them in. So I'm going to go ahead and put 1, put 2, and now we're going to solve this. So x plus 5x minus 6 equals 180. So we get 6x, I'm going to go ahead and add 6, is 186. And then if I divide both sides by 6, we get x is equal to 31 degrees. I should just say 31 because we don't have the angle yet. So find the measure of both. All right, so we're not done. So the measure of angle 1 is just x, so we can say, hey, that's 31 degrees. But the measure of angle 2 is 5 times 31 minus 6. So we end up getting 149 degrees for the measure of angle 2. So the measure of angle 1 is 31, the measure of angle 2 is 149. We can add them and double check. 31 plus 149, that does give us 180 degrees. So it checks out. Example 3. Oh, they're giving us some more algebra. So find x. All right, I'm going to highlight that because that's what I want to find. Find x. I don't need to substitute anything back in now. So that, and hopefully yours showed up, this right here should have a perpendicular symbol in it. So that KO, line KO is perpendicular to line HM. So I'm going to highlight KO and HM. So those are the two lines we're referring to. And that means they need to be perpendicular, so that needs to equal 90 degrees. Well, if I look at this 90-degree angle right here that I put, that's comprised of two angles. So if I add those two angles together, it should equal 90 degrees. So we're going to do 3x plus 6 plus 9x is equal to 90. So 12x equals 84. Sorry, I combined like terms and moved my 6 to the right side. And then when we divide both sides by 12, we get x is 7. All done with example 3. Moving on to the last problem, example 4. It says determine whether the following statements can be justified from the figure and explain. So the measure of angle VYT is 90 degrees. So there's a lot of different things going on. They didn't specifically tell us that that is 90 degrees. They don't even have a little box there to tell us it's 90, so we have to look and see, are there any context clues? What I do notice is that the angle that's adjacent to it, which, let me get a different color, which is XYV, they did say that that was 90 degrees. And XYT is a straight line or two opposite rays, so that must make that all 180 degrees. So this right here must also be 90. Okay, we can say it forms a linear pair I guess I should say with an angle, with angle XYV, which is equal to 90 degrees. Okay, so that's our response for part A. Part B, let's erase all these lines. They're probably going to talk about different angles. It says TYW, TYW, and TYU, TYU are supplementary. So this angle here and this angle there, just to make it a little more clear. So supplementary means 180 degrees. What we know that both of those angles form a linear pair. So we're going to say yes, angle TYW and angle TYU form a linear pair. Okay, the reason we know that it is 180 degrees also is because they put that little right angle symbol there, so I know this side is right, so therefore I know it's 180 degrees. That would be another way that we could say it, but a linear pair is also 180. All right, last one. It says angle VYW, oh, let's erase all this, VYW, so VYW, that little angle, and angle TYS, TYS are adjacent angles. So adjacent angles must be side by side, meaning they share the same vertex, which both of these do, but they also have to share a side. And these two do not share a side. So we're just going to put no. They do not share a common side. All right, that's the end of the lesson.